Thank you for introduction. I'm Velibor Ilić, and today I will present a presentation about active learning, but actually I will more speak about data labeling. First, I would like to ask you a question. How many of you collect data and label yourself? Could you raise a hand? Almost half. Okay. Next question. Is that data? How big is your data set? Is it more than 100? Please raise head. Okay. Next question. More than 1,000. Okay. Decreasing. Let's see. More than 10,000. Okay, we still have somebody. More than 10,000. Okay, one here. Okay, more than 1,000,000. No, nobody. Okay, just in a case. Okay. Today I will present a few of my papers related of active learning. First one is active learning using self-correcting neural network, and after that I will present other paper, Alvod, active learning for weekly labeling using supervised object detection. That paper is published on ICCV. Also, there is one small paper that we published in some local conference applying active learning in NLP domain, and after that I will speak about some future idea how we could apply active learning in some new technologies. Okay, this paper I published with Jovan Tadić. He was at Berkeley lab at that time. Now he is working for Apple. And let's start with some introduction how we train neural network. First we start with collecting data, and then we need to label that data. And after that we split that on some part of that data we use for training, some for validation, some for testing. And then we train some model with that data, and we could use test data to see how good is that training. We could estimate quality, how that data is could precise predict what we want. And if we are happy with this, we start using that neural network in a real life system. But in that time, if we put something on the input, the neural network will give us some values on the output, and we don't know if that is correct or not. If we really want to see if that's correct, somebody needs to check that data. But usually if that model is working somewhere without human supervision, we don't know if prediction of that model is correct or not. And how I started with this, I didn't plan to work on the active learning, but I had some project where I need to label a lot of data. First one is this one. You don't see my screen. Okay, too bad. Never mind, I will try to explain you. I have a video, if you see in top corner. This image, it's a project for the railway company. We have a camera in front, and we have 7 fields to detect do we have a grass or not, and after that is PLC that controlling sprayers to, I don't know, eliminate that grass. And for that prediction, I was trained a neural network, 2 from the side that's used for detecting bushes, and I have also some field that checking railways tracks and area left hand side from that network. And in a total, I needed to train more than 10,000 images to this network be working correctly. And at the beginning, I started with developing some custom software for data labeling. And my idea is to find some student then that will help me with this labeling. But I was at the end complete that data labeling by myself in just 2 or 3 days, more than 10,000 images. And how I did it? First, I try with this approach. This is one image extracted one frame, and I was try to visualize that fields over there, and I was clicking, and I realized that that is very slow. Then I develop this part. Then I could select images what is labeled with grass or without, because in that way it's really obvious if something is labeled wrongly, how to correct it. But still, that is not fast enough. And then I try something else. I label some quantity of these images, train neural network, and use that neural network to predict labels on unlabeled images. And then I check it in this part of the software, and it was easy to correct what is wrongly labeled. And then I train neural network again, and I repeat the process several times. And instead of labeling everything, my job was actually becoming correcting neural network prediction, and that was much faster than if you are working on a problem where you need to label everything from the scratch. And later I have another project that's for Serbian Institute, National Institute for Serbian Language. In that project, they hired me to develop some OCR application, but for me it was an interesting challenge, because that was my master thesis 20 years ago, and first my impression, I tell them that OCR software already exists. Why should I develop something in 2019? And but when they explained me that they want to use OCR for Cyrillic, and also this is accented Cyrillic, and it seems that nobody developed something like that. And for me it was an interesting idea to dealing with similar project 20 years ago, and now I had more available tools. I didn't do that project from scratch like 20 years ago. I used a software called Tesseract that very well recognizing Cyrillic letters, but they didn't know how to recognize this accent. And I developed similar software, and I also use similar approach, and I realized that this is something that working. And I thought, yeah, maybe it could be interesting to publish paper about this, but for me, I didn't know how to call that paper. If I call it approach for data labeling, that doesn't sound seriously. And then okay, how to switch slide. Then I watch this YouTube video from Lex Friedman, state of art about deep learning in 2020. And in the middle of his presentation, he showed that algorithm, and he talking about active learning, and he said that that is something interesting trend in machine learning at that time. And then I know what was the name of this technique. I didn't invent anything new, But I started reading some papers, and I was at the beginning really disappointed. I realized that people was published a lot of paper in the last 20 years. And then I said, okay, never mind. I was invented, how we say, hot water. And I thought that I will not publish anything, but I still try to read some paper and realize that there is some differences in techniques that I used and what is published in other papers. And here on this slide you can see how usually process of active learning look like. You have a human annotator, then label something, then you train a model, and you apply it on unlabeled data, and you somehow select which data you will check and correct. And here it's some, how to say, approach how you can use active learning. I was used something that is closely to first technique. You have a pool of your data and you label something and you have some approach how to identify what could be interesting that human annotator check. This approach here, it's stream-based. You can imagine that if you're applying active learning on some data, you don't check a whole data set, you check one by one item from data set, and if you find something suspicious, you immediately ask a human annotator to check and correct that data to see what you will do with this. And there is third approach. You can, if you find something similar, you can generate by synthetic data. And here it's some other techniques of active learning that I found in the literature. I don't go in detail how they look like, but mainly most of this data using one neural network and some techniques here using some mathematical expectation to detect what could be a good candidate to check it. This neural network here using several neural network that is trained with the same data, and because if you're repeating neural network training, you will not get every time same predictions. There is always some small differences, and you can compare it. And here is also some other techniques that I found in the papers. And also, what I show you, data what I use, it's not very well. I don't think that a lot of people know about my project, and I decided that I use some standardized data set for paper that I will publish about active learning. I used NIST data set, NIST fashion, and CIFAR 10. And I treated this data set like they are not labeled, and I developed some automatically Python script that if I need some assistance of human, actually I didn't checking what's going on that images. I was asking that script that fill me correct labels how they are labeled in that data set. I started without label it, and when I need human assistant, I call that script. And also because I wanted to have some consistency that see what's going on, I was used that convolutional network. It could be any other architecture, but I decided to that one. And that's how look like my algorithm. This is same algorithm but presented in a two different way. You have letters P1, P2, P3, this is processes, and D1, D2, D3, and so on, this is data. And how it looks like. First, we having some your data set that is not labeled, training data without labels, and then I ask some human annotator to select some small amount of items from that data set, and human annotators, this is just randomly selected data set. In that project I used 1,000 of labeled data, but the data set having first two 60,000 images, and CIFAR 10 having 50,000 images. And human annotators, or in this case script, manually labeling this data. And I used first neural network. I trained it only with manually labeled data, and this neural network predicting labels from the rest of the data set. This data over here, I don't predicting, because I just copy labels from here, because human annotators check it, and I consider that that should be correctly done. And this part is automatically labeled. And then in this moment here, I having a whole data set completely labeled. And then I train next model and predicting new labels from the whole data set, like here. And in this part here, I'm comparing, now I'm having labels from the same data, two pairs of the labels for the whole data set. One after training first network, and second after training second network. And I could simply compare these labels. You can imagine that this is just textual CSV files, and it is easy to compare. And you can identify a few groups of the data. First one, I call it C1, where labels are identical here and here. And we can consider, if somebody is manually labeled, neural network predicting that labels exactly as we want, that should be fine. But here we having some differences after second neural network predicting manually labeled data. We having different results, and that could be maybe case if somebody wrongly labeled data. That was I later realized that we could use active learning also to detect if human annotators even wrongly labeled some data, but I will talk about that later in more details. And this group of data here, it's let's say most interesting in this moment. This is data that human didn't look at before. It is automatically labeled, and it is different. Prediction is different from this network P2 and the network P3. We having some differences, and obviously one of network making errors, and we ask help of human annotators to decide which network is correct. But even because this data set having 10 classes, in some situation, very rare, could be possible that both networks could be wrong. But this is a rare situation. And also we have some data that both network predicted identically, and we don't need to do anything with that data. We didn't, nobody look at that data, but we have a confirmation of that, two networks train differently, predicting similar. And then this data, we ask human annotators to check again, and we have some set of data that is human annotators again look at, and we take that data and add it here in a test of, in a data set of manually labeled. Yes? No, if something is different, I was treated that human annotators could decide. But that's a very good point. That could be something maybe for future approach, that if you train neural network to ask us to have a feeling which model is more confident, and treat that you don't ask human annotators every time. Okay, and when you put this data, this process is iteratively repeated. And on this slide, you can see how results look like. This is MNIST data set, and for my surprise, it seems that only 6% of data, or 3,600 from 60,000, it's enough to have even better results. That was also my surprise, that actually if you select most informative data from the data set, you will have even more accurately prediction than if you train neural network with whole data set. Even if you use the data set that are as it is downloaded from the internet. MNIST data set, it seems that it's easy to understand. With next data set, NIST fashion, you need a little bit more data. It's 23%, but still it is much less data for human labeling. And CIFAR 10, it's a more complex data set, but still it is, you don't need to label everything. And here you can see numerically how it looks like. Good side of this approach is because you are reducing amount of data that you manually label it, but bad side of this approach is that you need to train your model several times, but that also takes some time. Sure? Sorry, I didn't hear you well. First actually that's this line. You can see how it looks like. You are every time finding items from the data set that it's hard for neural network to detect it. Actually, this is also one way for finding the different difficult cases from your data set. And if you look at the yellow line, that's how looks like a prediction of on the manually labeled data. That neural network, if you always select these worst items, that when you can, when where is differences appear, at the beginning you have good results, and then in one moment, because you're always putting difficult cases, your prediction, if you're predicting only on that items, accuracy will fall. But in the same times, if you see what's going on the other data, accuracy going up. And same situation, it's also on the other two data set. And here you can see how looks like amount of the data, what was appearing in the difference. In first iteration, you will have a lot of items that is different. And for example, in this data set, it's less than 900 images, and next iteration, it is almost the half. Less than 400, and from iteration to iteration, this number of the differences will decrease. And because I do this research for the publishing in paper, I put this model to do 35 iteration, just to see when it will stop to finding differences. But if you are working on a real life situation, you don't need to have so many iterations. You can have maybe 3-4 iterations and say, okay, I am happy with these results, and I will stop here. And this is something similar that you ask. This is differences. If you are considered that the first network, it's manual, trained with only manually labeled data, you can say maybe this network having better results. And here is a number of errors what you find in predictions of that data set. At the beginning, you find 35 errors in that data set, but it seems that trend line is going down. First network becoming more efficient, and from iteration to iteration, looking in percentage, error is decreasing. Okay.
Yes, the last slide. What does the one session? What is the one session?
One session, it's if you remember this algorithm, you have manually labeled data, first network, second network, comparing, human checking, and going back. That's one iteration. Okay, and just to see how it looks like, if we see in the numbers how this training takes. This is a PC configuration that I use for that training. It is PC with Intel i9 processor and NVIDIA graphic card, and everything is automatized. So if I send something to human annotate, we can consider that it doesn't take any time. Because I used the script, and this is only time for the training that network. And because I have 35 iteration, if I train neural network only once, I will have only one iteration. But here I'm saving some human time, but also it's not very efficient for computer times. But I think that human time is more valuable. And on this table, it is one interesting question from a reviewer when I submit that paper. He asked me, what will happen if you have some wrongly labeled data in first data set that is manually labeled, in first 1,000. And just for experiment, I intentionally put 20% of errors in that data set. So if I have 1,000 manually labeled images at beginning, and 20% is 200 images. In first iteration, this algorithm found 94 images. That's almost 97%. Just in the first iteration, we found a lot of images that is wrongly labeled. Okay. And soon as I publish this paper, maybe you know this, it's Andrew Ang, and he's talking about MLOps. And it is very similar. If I know his presentation before I published my paper, I think that I will put some ideas here in publication, but I published before. And it seems that Andrew Ang, a lot of talking about if you have your data set, a lot of people will focus how to use a more efficient model, or maybe to develop some more efficient loss function with very complex equitation, but sometimes it's you can do something that is more simpler. Just check your data set and see if you have some errors. You will get much better results with this than if you are using some complex stuff. And some conclusion, for me, this one, it's really interesting that if you have some big data set, not every data item in that data set having equal value. With this approach, you can identify what is the most important items in your data set, and you just need to label it this, and the model will figure by itself how to deal with other data set. But you need to find somehow what is most important data. And this approach, reducing manual labeling, it is also interesting for error detection. And this one is also interesting. For example, if you have some data set with beginning, and you start with this data set, you train your model, you are happy with model performance, and you collect a new amount of the data. Using this approach, you can very easy to add additionally, you can expand your data set without a lot of human effort. And then I will present a new paper that I published in ICCV in Paris. That's collaboration with Vladimir Pavlovich from Rutgers University and Yu Ting. She was his PhD student, and we joined our research. They are working on weekly labeling, and I was suggested that we could apply active learning on his and on their approach, and the results is this paper here. And first difference, what we need to figure in paper that I present you, I was using convolutional neural network that that need to classify some data. And in new project, we was working on object detection problem. So you can see this data set is much simpler. You have one image, and that image having one class. But because in a new project we was working on object detection, one image could having several instances of the labels which could have different classes on the same images. So you cannot say this image is wrongly labeled. Usually it is always in which percentage it is wrongly labeled. So some labels could be missing. Yeah, on this slide it's look like how it look like. This label it's correctly labeling about object that we want to detect, and class is correct. And there is some different problems what we can dealing. For example, this is this is a wrong class. This label it's not on correct position. Some class could be at the wrong position and with different class, and also you can have several objects in one bounding box. And I'll skip this and try to explain what we did on that image. Also, what is interesting in that paper, if you remember in previously paper, we were starting with selecting some items that will be manually labeled. In this data, we immediately starting with training neural network with synthetic data. So nobody did any labeling in beginning. Here we have some software application that could generate synthetic images, and when you're generating synthetic images, you know what we did with pizza images, because pizza is a very hard problem to detect what you have on the pizza, even for human. But if you're using that software for synthetic images generation, you know what you're placing on the pizza images. On that slide, you can see how it looks like. You have, for example, table on that you put pizza base, and you're placing some cropped images all over the background, but every time when you place somewhere, you know what you are placing and where you are placing. And you can use that for the training first model. And when first model is trained, we are switching in a real domain. We are putting this trained model to, at beginning, recognizing labels and finding their location on the real pizza images. Of course, at beginning results are not perfect, but still it is good enough that we trying to find what is a good candidate for human annotator. And what human annotator will need to do in this situation is also doesn't need to label everything. Goal of human annotators is just to correct bounding boxes and checking the classes. It is also much simpler problem than if we work from beginning. And here I will, okay, idea is to show you how this application look like, but it seems that it is shared only PowerPoint, but not my application. Never mind. It is web application that you can first, with few mouse click, because on the one pizza image is, just a second. On the one pizza images you have several objects and several classes. It becoming very obvious if you have possibility to select object by classes, and then you see if something missing, and you can easily add or change classes to something else. We develop a web application that is very user-friendly to do that, and that's really saving time. And what else? Okay, my main, our main data set was this real pizza, 10 classes, that mean pizza 10. But also we check performance of this approach to data set Coco and Wok. And here you can see how looks this interface of web application. I wanted to present you live presentation of that software, but I could show you from the slides. This is images that, if you remember in previously paper, what is selected for human annotator. And here it is listed that images, and you can see on the images that is also interesting. Before human first time look at that images, it is written here what kind of content you can find on that images, and that's how looks web interface. Here you have content that you can select, and with a few mouse click you can correct it. And here it's result. You can see progress of the training from iteration to iteration. Also there is some numerical results. I will not go in detail. And we also, as I said, develop here on our institute another active learning approach. It is in area NLP. We had a project for the COVID, opinion of people on the Twitter. It is a sentiment analysis, and we also developed some web application that helping people to find which items it needs to be checked. And for the end of my presentation, there is few idea what I think that could be interesting for the next paper. It is combination with active learning with explainable AI. I think that will be very interesting to see if your model making a wrong prediction, that you have some visualization why. What your model thinking, why some items it's assigned to different classes for that, and this shop having possibility to visualize that data. Also, it will be very interesting to see how active learning will be used for the model that on semantic segmentation, because it is semantic segmentation. It's some kind of classification, but classification on the pixel level. And here will be interesting to develop some very user-friendly application that will help user to correct these images. And also, for me, it is interesting to see how active learning could be combined with reinforcement learning. Reinforcement learning is a technique that actually doesn't require human involvement, but maybe if we combine it with active learning, we could identify, we could see from iteration to iteration of reinforcement learning what we could track progress. What is different from one model to another? Or maybe we could help reinforcement learning to some human advice of what we'll do in some situation if having some different results. And the last thing is applying active learning in training a large language model. This spring I was, it was one call of OpenAI about to write some project proposal, and I was thinking maybe to apply something with a combination active learning with training a large language model, especially because for me it's hard to imagine, but a lot of people talking about that for the training next generation of large language model, whole data that is available on the internet is not enough. We will need to generate new data sets synthetically, and especially because large language models even today having possibility to write nicer text than a regular human, but we don't know if that text what is generated by human it's correctly or not. Maybe it's some kind of hallucination. And my idea maybe how we could use active learning for this is to check this synthetical data and how it is different, and also what is how we could use active learning. Maybe we could somehow replace human with a large language model with some not very precise description, because if this is interesting slide, for example, our analogy for most of people that human is superior about machine learning models, but sooner or later we will have a machine learning model that it is most efficient. But if we leave machine learning model to train itself, we need to find a way how they will stay on the track that doesn't finish in some weird situation, that especially if we are generating synthetic text. And before the end, that is one invitation for you. I was invited to be guest editor in this journal. If you have some paper that you are planning that is related to symmetry, please contact me and I could give you some discount. And thank you for attention.